Hello everyone. This is the first video in a series dealing with an introduction to vehicle stability. In this video we will learn about the introduction to vehicle stability, we'll talk about Newton's 3 basic laws of motion, and discuss basic terms related to the movement of bodies. Like any other body, when a vehicle moves along the road, Newton's laws of motion apply to it. In order for us to understand the car's reactions to the forces acting on it, it is important to understand the 3 basic Newton's laws that act on the vehicle. In this video, we will discuss Introduction to Vehicle Dynamics, Newton's laws of motion, basic terms in physics. Physics is a branch of the natural sciences that deals with material and energy, and the interrelations between them. Mechanics is a science that deals with the effect of forces on bodies in motion, or at rest, and it's part of the physics. Kinematics is a branch of mechanics that describes the motion of bodies, without reference to the forces acting on that body. Dynamics is a branch of mechanics that includes the study of the movements of bodies and the forces that generate those movements. Motor vehicle dynamics is a part of the dynamics, which deals with the influence of forces acting on vehicles, and the study of the movements of vehicles. Every body strives to persist in its state, to remain at rest, or to continue moving in rhythmic motion at equal speed, and in a straight line, as long as no external force acts on it that changes its state. Hence, the rest of the body, or rhythmic movement, has equal status in terms of the law of perseverance. As early as Aristotle's time, it was argued that rest is the natural state of the body, and that in order to move the body, an external force must be applied to it, and that when the force is stopped, its movement decreases until it stops. In a later period, Galileo and Newton found that the body does not stop on its own, but rather the forces of friction and air resistance cause the body to slow down, and if it were not for these external forces, the body would continue to move straight and at a constant speed. Even if an external force acts on the body in some direction, and an external force is the same in the opposite direction, the two external forces balance each other. In fact, when the sum of the external forces acting on the body is equal to 0, the body continues in its state of rest, or in its state of constant motion, without changing direction or speed. When the body is standing, without movement, it will remain there forever, and even raise cobwebs as in the illustration, as long as no external force acts on it to move it from its position. When the body is in rhythmic motion, it will continue in this motion forever, as long as no external force acts on it that changes its speed, or its direction. When the body is at rest, or in rhythmic motion, its state can be described using the following formula. Sigma F equal to 0. The force acting on a body is equal to the multiplying of the mass of the body in its acceleration. Any body on which an external force acts, changes its velocity in direct proportion to the force, and inversely proportional to mass. Body mass is a measure of how much material the body contains. On Earth, due to gravity towards the center of the Earth, mass determines body weight. The more mass the body has, the heavier the body, and the more force it needs to move. Outside of Earth, for example on the Moon, a body with the same mass weighs less. The force acting on the body has a direction, which also determines the direction of the body's acceleration, resulting from the application of the force on it. That is, the force acting on the body is a vector force. Newton's second law can be described mathematically using the following equation. F equal to m multiply a. Every action has a response, equal in intensity and opposite in direction. Just as the man in the illustration pushes the wall to the left, so the wall pushes the man to the right, with exactly the same force. As an example of Newton's third law, when a car collides with a wall, the car exerts a force on the wall in the direction of its movement, and the wall in response exerts the same force on the car, in the opposite direction to the direction of the car's movement. Of course, the car will be damaged as a result of this collision, and probably nothing will happen to the wall. Since the force acting between the two bodies is the same, and is equal to the mass multiplied by the acceleration of the body, Newton's third law can be described mathematically using the following equation. ma equal to minus ma. The man in the left side pushes to the right direction, and the man in the right pushes to the left direction. The same force, but the opposite direction. Therefore it is marked by minus. Mechanical energy. A concept describing the sum of potential energy and kinetic energy stored in a moving body. According to the law of conservation of energy, in an isolated system, the total mechanical energy is constant. If the body moves in the opposite direction in the direction of weighing the conserving forces, then the potential energy stored in that body increases. For example, if a car is moving and climbing up a mountain, it is moving in the opposite direction to the direction of the car's forces. As the car climbs the mountain higher, it accumulates more and more potential energy, which it will use in the future as it moves down the mountain. If the speed of the body changes, then the kinetic energy of the body changes. When the car is on the top of the mountain, it has potential energy, which the car uses to descend down the mountain. In any system, where there are no conserving forces, mechanical energy becomes constant, so it can be used for calculations. In an elastic collision between two bodies, the mechanical energy is conserved, but in a plastic collision between two bodies, some of the mechanical energy is converted into heat energy. Kinetic energy. Also called the energy of movement. Energy of the body by virtue of being in motion. Kinetic energy depends on body mass, and its speed. Potential energy. Energy which is stored in the body, as a result of an external force acting on it, or a force within it. Potential energy can be converted into other forms of energy, such as kinetic energy, heat energy, or other potential energy, and can also perform work. Thermal energy. Also called heat energy. It is part of the body's internal energy, which is related to the body's temperature. Energy conservation law. One of the basic conservation laws of physics, according to which the total energy in a closed system is a constant amount that does not change. That is, the change of energy in any closed system is expressed only by the change in the shape or position of the energy, while the total amount of energy always remains constant. Mass conservation law. Also called the law of conservation of mass. A conservation law according to which a mass of any material cannot appear out of nothing, and cannot disappear. It only can change its form. Momentum conservation law. One of the basic laws of conservation is that in a closed system, where no external forces operate, total momentum is preserved. The momentum is equal to the mass multiplied by the velocity of the body, that is, it is the amount of motion. It is described by the equation momentum equal to m multiplied by a. Time is a basic characteristic that describes the sequence of events in space. According to modern physics, as described in Einstein's general theory of relativity, time is a property sustained by the material itself, with each object having its own time, which is determined by the speed of its motion. And when time is relative, rather than absolute, it is affected by phenomena in space that distort its movement. However, at values accepted on Earth, for the study of body movement, and for the study of traffic accidents, time can describe a sequence of events, and be measured, using a clock. Mass is the physical size of a body that determines its weight and resistance to velocity change. The acceleration of the body depends on the force exerted on it, and its mass. Movement is the change in position of a body depending on time. It is measured using speed. Changing position to a long distance in a short time means high speed. Changing position to a short distance in the same period of time means a lower speed. The movement is relative to its surroundings. Acceleration and deceleration are the rate at which a moving body changes its speed. When the speed of the body increases over time, it is acceleration. And when the speed of the body decreases over time, it is a deceleration. In fact, deceleration is an acceleration, with the sign of minus aside. Freefall gravity acceleration. The rate of change in the speed of a body falls under the influence of gravity alone. The acceleration of free fall does not depend on the mass of the body, but only on the strength of the gravitational field, or gravity of the Earth. Radial acceleration. When a body moves in a circle in rhythmic motion, its tangential velocity is constant. That is, the size of the speed is constant, but the direction of the speed constantly changes, depending on the radius and circumference of the circle. Therefore, the body moving in a circle has a component of acceleration towards the center of the circle all the time. This is a radial acceleration. If you liked this video, please like. I invest a lot in publishing professional material for free, for everyone. I wish you to subscribe to the channel, and turn on the bell, so that you will receive notifications each time a new video is published. Please share with your friends, and I would love your comments as well. This will help a lot with YouTube's algorithm. In this video, we discussed an introduction to vehicle dynamics. We talked about Newton's 3 basic laws of motion, and talked about some basic terms in the dynamics of bodies. I hope you will benefit from the information learned. And until next time, drive carefully.